Okay, now we're talking about the force, equilibrium of a particle. So at this moment, we know a few things. We know the force, how to convert a force into a vector representation. We know how to, if I have a force, I know how to decouple that into x direction and y direction. So what are we going to use that? If you have an object, F1, F2, F3, and F4. And F5. Okay, and again, in this class, we're talking about things never move. The force equals to 0, which means I need to decouple this force into 3 directions, x, y, and z, and all of them equals to 0. Okay? And at this moment, all the forces are going to be concentrated at the same location, which means we are talking about a particle instead of rigid body. The rigid body is going to be in chapter 5, but in this chapter, we only deal with all the forces applied to the same point. So if it's applied to the same point, we only need to take care of force. We don't need to worry about the moment. So some of you guys might take this force before, and you are confused with the moment or anything like that. Don't do that in this chapter. Chapter 3 only deal with the force concentrated at the same point. Okay. But when we have a force equation, the next thing we need to do is an important thing. Free body diagram. Even though all the forces are concentrated at the same point, I still want you guys to draw the free body diagram because it's a good habit. In particular, if you have forces involved in the problem, you always need to use this kind of diagram to show yourself how the forces are distributed. Okay. So we talked about the free body diagram yesterday, and if you have multiple forces, how are you going to draw that on the object? Now, let's work on the example today. Okay, so I have just a plate used to connect 4 members of a planar strut that is in equilibrium. So I have 4 struts, 1, 2, 3, 4, A, B, C, D. And assume the weight of the members and the gasket plates are 0. Compare with applied loads. Find the magnitude of the loads FA and FC acting on members A and C. Okay, so again, for this specific problem, though this looks like a rigid body, but all the forces, if you extend the lines of individual forces, they're going to be applied to the same point. In this case, it's O. So when we see this kind of problem, it is actually equivalent of a particle. So before we start, we would like to identify what are given and what we need to find. So in this specific problem, we are given FB equals to what? 500 pounds upwards. And we are also given FD equals to 1200 pounds equals to that direction. Okay? What do we need to find? And we are given that theta for FC is 60 degrees. Those are the information that we know for this problem. We would like to find out two things: the magnitude of FA and FC. Okay? So let's start. I have four forces acting to the system, so I would need to have a free body diagram for this thing. So as I said, all the forces are applied to the same point if you extend the direction of individual forces. So let's start from we have another given force, which is FV, that equals to 500 pounds. Right? Now, we have two forces which is not given, but we do know their directions. That is FA and FC. So, since this is on a plane, X and Y, so what I need to do is to decouple everything into X direction and Y direction. And all those two equations equals to what? 0. So with that in mind, it's going to be 400. Right hand side is my positive direction. Left hand side is my negative direction. So 1200 minus FA, and the other force is going to be FC cosine 60 degrees. Is this going to be positive or negative? Negative. This equals to 0. If you arrange that a little bit, you're going to find FA plus 0.5 FC equals to 100. For F1, it's going to be 500 pounds. That is FB minus FC sine 60 degrees. Do we have any other vertical forces in this system? No. So it's going to be this. If you arrange this equation a little bit, you're going to have something like this. How many unknowns do we have here? 2. How many equations do we have? 2. So can we solve for all the unknowns? We do. So if you take this equation and this equation, you're going to find FC. You can calculate FC directly from here. That is going to give you 577 pounds. If you put 577 pounds into this equation, you're going to get FA equals to 912 pounds. Those are my answers. Is that straightforward? Everybody understand what I'm talking about? Question? No? Okay. If we don't have any questions, let's move on to another example. Am I going too fast or is too slow when I'm teaching the material? The speed is okay for you guys? How about my accent? Everybody understand what I'm talking about? My writing? Everybody recognize how I write on the board, right? Okay, good. Okay. Second problem. Okay, a 50 kilogram mass is suspended by a boom, which is this one, hinged to the wall at one end, tied to the wall by the cable. Determine the tension in the cable AB and actual force in boom AC. So we need to find the forces along this cable and this boom. Okay. So we need to find out what are given and what we're trying to find. Okay. We are given that mass equals to 50 kilograms. And the two forces of this thing and this thing, they are 45 degrees and 30 degrees. So those are the information that we know. Now, based on the configuration over here, there are several common sense you guys need to know. So this is the cable. Are we going to have a force to this direction? Let's name this 1. Or to this direction, 2. 1 or 2. How many says 1? How many says 2? It's going to be 1. Why? Because when we use a cable, it will only provide force when it's tightened. So if you are trying to support the force to this direction, it's going to be what? Stay. When it's stay, the force is 0. So in other words, the force on the cable, either you have more tension or you are going to have 0. If it's stay, it's not going to provide any force. For instance, if you know this boom can support everything itself, this cable is going to be something like this. It's going to be stay. When it's tightened with the angle given in this problem statement, it means that the tension along this cable is going to be along this direction. Okay? We need to find tension AB. We need to find force. So let's start. Okay. We want diagram. In this case, all the forces are going to be concentrated at point A. Let's draw the coordinate first. Over here, I have my weight. How much is this one? Which kind of unit we're dealing with here? English or metric? Metric. So the 50 kilogram, is that mass or it's a force? When it's a mass, what do we need to process? Multiplied by gravity. What is the gravity in metric unit? 9.81. So 50 multiplied by 9.81 is going to be 491 newton. Now, I'm telling you, the force along this cable is tightened to that direction. So, we know EAB is going to be with 45 degrees along the x, with respect to the x-axis. Now, you have a force over here, you have a force over here. It got the tension to this direction, right? So the boom is supporting everything and prevent everything from moving, which means the boom is going to have a force that support everything and keep everything from not moving. So with that said, this is going to be 30 degrees, and this is going to be F AC. So far, everybody understand the free body diagram? Any question? Then, if you know what I'm talking about over here, the next step is to write down the equation of equilibrium. That is equals to cosine 45 degrees. Is that positive or negative? Negative. Why? Left hand side. FAC cosine sine 30 degrees from FAC. Is this positive or negative? Positive, because it's going to right hand side. Equals to what? 0. F1 is going to be AB sine 45 degrees FAC cosine 30 degrees and 491 newton. Positive or negative for the tension? Positive. From the boom. Positive. For the weight. Negative. Equals to what? How many unknowns we have here? How many equations we have here? Can we solve for the unknowns? Yes, we do. So if you use your algebra to solve for this equation, you're going to get EAB equals to 254 newton. FAC equals to 359 newton. We don't need to specify the direction. There's a reason we're going to talk about that in chapter 5. But at this moment, you just need to calculate for the magnitude. Any question? Is that straightforward? Everybody understand what I'm talking about? Okay. So, for this kind of problem, the solving procedure is step 1. I would like you guys to follow what I'm writing down here. Some of you guys that is a standard procedure. We're not solving this kind of problem. You need to identify what are given and what you need to find. Because some of you guys has a habit reading the problem and just start to solve for the unknowns. But there is a mistake over here, because sometimes you see the figure like that, and you have some idea what the unknown existing in the configuration, and you just start to solve for that. However, a lot of time, it is not something the problem is really asking. So before you start your solving process, be sure you identify what are given and what you need to find. In other words, you need to rewrite the problem in your own language so that you know what the problem is asking you to solve and what is the variable you need to come up in the end of the solving process. Okay, so this is the most important thing you guys need to do. Okay, then the next step. If we have force involved in the problem statement, the next thing you need to do is to draw free body diagram. Okay, when you draw in the free body diagram, there are a few things you need to know. You need to include all the forces. That's something you need to do anyway. The other thing is define which direction is your positive direction. So in this case, in most of the cases, right hand side and upward are my positive directions. But it is not always true. Sometimes, in order to solve the problem faster, you need to tilt the x, y direction a little bit so you know what's going on. We are going to talk about this when we are dealing with friction, because when we are dealing with frictions, sometimes it's on a slope. When it's on a slope, it's better for you to tilt the coordinate a little bit according to the angle of the slope. But we're not going to use that until we are talking about the problems in chapter 7 or chapter 8. But before that, you still need to identify your x direction, y direction, and which directions are your positive. Normally, it's going to be right hand side and upwards. That is something you need to draw over here. Because if you don't do that, a lot of time, you guys is going to have positive, negative number symbols everywhere, and I have no idea what you're talking about. Seriously. Then, once that is done, equation of equilibrium. What is this? Sometimes okay, just write down x, y, z. They are all equals to 0. Again, in this case, we're not talking about anything moving. So all the forces equals to 0 in chapter 3. Next step. Solve for the unknowns. Okay? That is how you actually deal with the unknowns in those 2 or 3 equations. Okay? So be sure you follow the equation, the procedures over here. Then you should not be too much deviated away from the correct answer if you identify this thing correctly. Okay? You might make some calculation errors. That's fine. Don't worry about it too much. Even though you know, okay, I make some mistake over here. Don't spend your time trying to go back and check for your answers, because if you still have 2 or 3 other problems you need to solve, just leave it alone. If you have time, come back and check for that. If you don't have time, just leave it there. I won't say it's wrong if the procedure is correct. Okay? So just be sure. Question? Then I think I still have time. Yes. So we're going to move on to a 3-dimensional problem. Three-dimensional problem is the most confusing problem you guys are encountering when you are dealing with the problem. But it's actually not too much difference from the two-dimensional problems. It's just you just need to write down all the equations in three. You need to x and y and z equations. Oh, that's all. Okay, I have a traffic light that is 100 kilograms, supported by a system of cables as shown in this figure. Determine the tensions in each of the three cables. So let's name this one as O. Okay, so I have this one 100 kilograms, and I need to find out all the forces. This cable, and this cable. Keep in mind, in this case, it's a little bit different from the problem we solved earlier. This cable is different from this cable, and this cable is different from this cable, which means TOA, TOB, TOC, they are all different forces. I'm going to follow the procedures over here and solve for the problem. Okay. Question about the problem statements? So I'm given the load is 100 kilograms, which means the force over here needs to be multiplied by 9.81. We need to find TOA, TOB, TOC. Let's start. That's straightforward. But the next thing is we need to follow something we learned in chapter 2. That is, we need to identify the position vectors for TOA, TOB, and TOC. Once we figure out TOA, TOB, and TOC, we need to find a unit vector. When we find a unit vector, we need to represent all the forces in terms of x direction, y direction, and z direction. For all the forces, how many forces we're talking about here? 1, 2, 3, or 4? This cable has force. This cable has force. This cable has force. Other than those three cables, do I have an additional force in this system? Which one? The weight. So how many forces we're talking about here? 4. Okay, keep that in mind. Is there any force we know already? Weight. Very good. So you guys know what I'm talking about. So, okay. For OA, it's going to be so for you're going to have negative A I plus 4J plus 5 K meter. For OB, we're going to have negative A I negative 6J 5 K meter. OC is going to be AI plus 0J plus 5 K meter. Okay? Those are the three position vectors in our system. So the next thing we need to do is to find out the unit vector. But before we do the unit vector, we need to calculate for the lengths of OA, OB, and OC. That's somewhat tricky. Just put OA equals to So you're going to get this number equals to 10.25 meter. This one is 11.18 meter. This one is going to be 9.43 meter. So far, any question? Everybody understand what I'm talking about? Nothing fancy. I'm just repeat what I'm doing, what I was doing in the first hour of today's class. Okay, so you need to identify the total length of this one, and this one. So what's the next? We got the length, we got the position vector. So what's the next? Very good, unit vector. And well, I don't really want to waste my space over here. So I'm going to do the force vector directly, because the unit vector is what? This divided by this. This divided by this. This divided by this. Okay, and we can just multiply all those things, all those three equations with force. That's our force vector. Does that make sense to everybody? So with that said, 5 POA becomes negative 8 divided by 11.18 POA I plus negative 6
Should be 10.25.
Huh?
Shouldn't that be 10.25? No, 11.13.
Oh, yeah. Oh, this is, I copied the wrong part. This is 8, 4, 3, 5, 10, 20, 25, 10, 25. Okay, so DOB is going to be DOB Okay, the total length is 11.18. And that is going to be negative 8, negative 6, 5. The OC is the same. So the total length is 9.43. 9.43. 9.43. The vector is 8, 0, 5. Is that all? Do I miss anything? The weight, very good. So the weight is going to be 100. Am I right? What do I need to do? 9.81. Okay. Positive or negative? Negative, because I define upward as my positive, so this is negative. So all the units over here are units. What are we going to do now? Equals to what? 0. Is that all? No. I need to minus 981. Okay. How many unknowns we have here? 3. How many equations we have here? 3. The solving procedure is going to be a little bit tedious, but you should be able to solve for the unknowns. If you solve all the unknowns, that's actually the last step over here. Then we get POA equals to 600 Newton. POB equals to 439 Newton. POC equals to 935 Newton. Those are my answers. Is that clear? Everybody understand what I'm talking about? So in this equation, in this specific problem, it's a longer process than this one. The first thing we need to do is to identify what are given and what needs to be found. And in this specific problem, we know the force over here, so you can draw the free-body diagram. And we know tension is like this. So this is TOA, TOP, TOC, and this is my weight. So that's my free-body diagram. Once I figure out my free-body diagram, well, since this is three-dimensional problem, it's going to be a little bit tedious because we need to find out the position vector, we need to find out the unit vector, then we need to represent everything in force vector. So if we figure out everything, we just put things over here. Then once you know how to present everything in force, it's going to be much tedious than two-dimensional problem because in two-dimensional problem, you only need to use cosine and sine, then you do everything. But here, you can't. You need to decouple everything in 3 dimensions. And once you figure out the 3-dimensional problem, x, y, z, all of them equals to what? 0. And depending on how many unknowns you have here, solve for the unknowns. Keep in mind, you only have 3 equations. How many unknowns you can have here? 3. If you find out there are more unknowns than the equations, you're doing something wrong because it's not possible for you to solve this kind of problem. So revisit step 1, 2, and 3 to find out, is there anything you misunderstand or is there anything you write down here wrongly, so you make a mistake. That we cannot solve for the unknowns. Okay, we're going to move up tomorrow.